Ladies and gentlemen, and we're now entering a pivotal segment of today's grand opening ceremony, a panel discussion that promises to be both enlightening and thought-provoking. Our esteemed panelists that explore the future of international scientific payloads and the importance of collaboration in advancing space, science, and technology. And joining me today are four distinguished guests from around the world. They are Mr. Niu Aimin, Vice President of International Cooperation from USPACE Technology Group Limited, and also Mr. Bernard Foing, Executive Director of the International Lunar Exploration Group, and also Mr. Yansong, Director General of Department of Education and Training from the Asia Pacific Space Cooperation Organization, and also Olivier Contant, Executive Director and academician of the International Academy of Astronautics. Welcome, gentlemen. And we will highlight some of the cutting-edge technologies in the space science, and also the role of scientific payloads in advancing our understanding of the cosmos. And let's dive right in, okay? And firstly, I want to know that what kind of space science payloads are you most excited to see in the near future? First, we start from Mr. Niu.
Okay, thank you very much for inviting me to address this global event. To me, I think the purpose of space exploration with scientific payload is to find opportunities for human beings to settle in other planets, and also to develop and mobilize resources on that planet. In order to do this, we need to send the land rover to the planets. For example, like US, China, and Japan, they have already sent lots of land rovers to the moon, Mars, and asteroids. But I think because there were no paved routes on the planets, so the current payloads, the land rovers, are easy to bounce and turn over. So it is not easy to adapt to the very complicated terrain on the planets. So I'm thinking I would be very excited to see some interesting payloads to be developed, which can be easily adapted to the complex terrain of the planet, which should be looks like a hedgehog and something like a ball with legs, which can be easily retractable.
Okay, so Mr. You want to have some payloads to land on the moon or on the Mars, these kind of land rovers, right? Yes. Okay, what about you, Mr. Foing?
Yeah, in terms of science payload, there is really work for all of you. Mm-hmm. Because first we can start about payload to observe the most beautiful planet, the Earth, to study, to understand it, to monitor it. And then, of course, we have to go to the next place, that's the moon. And on the moon, we have payload to understand the formation of the moon, its history, the science of the moon, but also what we can do from the moon. We could put telescope on the moon, we can detect, for instance, exoplanets there, and also, very importantly, payload of science on the moon. And there, Professor Deng, Yulin, would be very interested, because we have to see how we could expand life onto the moon. And then let's go a bit beyond. We want to go to Mars to search for the history of water, the history of habitability. Was there life on Mars? So we need to develop some rover systems, some drill to go in the subsurface, search for sign of life. But we don't stop there. Some of you will want to go even further. You will want to study outer planet systems. These are very complex systems, giant planets surrounded by icy moon that could contain subsurface ocean. And we didn't even stop there, because now in the galaxy we found stellar system around more than 6,000 stars. And so we have places that could be habitable. So we try to search for life. So it will be taking time to travel there. So we use giant telescopes to find signs of life on this exoplanet. And some of you will want to go further. You will want to study galaxies, you want to study black holes and the formation of the universe. So clearly, in terms of science, knowledge, discovery, there is work for all of you there.
Okay, Mr. Xu.
Thank you very much. I think one of the very important things to understand is that we have a number of platforms that we can put on scientific payloads, starting from a very modest drop towers to parabolic flights to low Earth orbit. And then we have this International Space Station and Chinese Station that can put payloads on board and then bring it back. And also we have exposed platforms. And also previously we mentioned about the Moon and Mars and beyond. The Moon, we have the Earth, the near side and the far side. And the far side has also have unique characteristics that the Chinese mission has achieved, which has less radioactive influences from the Earth than you can have astronomical observatories. So taking all these interesting vantage points that you can develop your payloads on board these different platforms is very important for the students to understand that we do have different platforms that we can use. So back to the question of most exciting payload and instruments that is coming up. I think one of them, I have two in my mind. One of them is the hard X-ray observatory that we're planning to launch for astrophysics and observatories purposes. And another one is the lunar missions on the South Pole, that we can find lunar volatiles in the future to pave the way for us to go far beyond the Moon. So we understand that we are studying the possibility of deposit of water and other materials on the lunar surface, that we are developing the scientific base, that we can further elaborate and study the lunar surface to better understand the formation of the Moon, and to also use that as a stepping stone for future missions. That is my exciting part.
Thank you. Oliver?
Yeah, well, I think we've covered a lot of different applications for payloads. What I'm excited on my side will be to do some payloads to understand more the problem of radiations, because if we're speaking about deep space exploration, then we'll need to, at some point, some people over there. And the International Academy of Astronautics have done recently some studies, actually in collaboration with a strong Chinese organization, the CASC, and we actually have some results that are a little bit, making us think that we definitely have to spend more time and resources to investigate this, because we have a lot of big projects for deep space exploration and learning exoplanets, understanding black holes and all that. But at some point, if we want to go and not only unmanned vehicles, but manned vehicles and people inside, we need to care about their safety. So I would love to see that. Also, higher resolution spectrometers will be very nice to understand, therefore, all these things, and maybe also developing payloads for nanosatellites. The smaller, the fastest, and we can have very high resolution. So improving the resolution in these nanosatellites will be also something probably very, innovating, and you have a lot of work in front of you to try to fix all this.
Yeah, exactly. As our guest mentioned, that the China space station is orbiting some 400 kilometers away from the Earth, and there will be a lot of interesting experiments that can be carried out in a microgravity environment. So next, I want to know that how can this kind of capacity building and educational initiatives that support the development of these kind of scientific payloads, as well as the international collaboration?
I think capacity building and education initiative is the most effective approach to promote international cooperation, because it can encourage the learning of scientific programs and encourage long-term partnership with industries, with every shareholders from the group, and very easy to create a long-term relationship with different organizations. Mm-hmm. So I think this is the best way to promote collaboration all over the world.
Okay.
So capacity building in the area of STEAM, science, technology, engineering, art, because that's innovation, creativity, and the mathematics, this starts very early. And I think our society now needs to have much more STEAM. Mm-hmm. We are a knowledge-based society. We need all these disciplines to develop, to create solutions, and that's where space can inspire at a very young age, so people to develop this innovation in many areas. Innovation in how we are going to use data now, using artificial intelligence, machine learning to analyze data on Earth and also on the Moon and solar system. Also, another very important aspect is the ability to develop soft skills, team skills, working together. And you have done that now for your competition, you have done some team projects. The next step, you can also do projects where you build together some projects, and it's very important to include early the international component, to have international teams, to have programs for exchange, so where we can bring some world students here, where we can take some Chinese students over the world and work on projects. And we want also to develop hands-on projects, because there you see the reality, so you don't live only in the computer or on your smartphone, but you also do experiment. We have also developed a program in Europe, we call it Euro Moon Mars, where we train space researchers, astronauts, and entrepreneurs. That's a new dimension as well. The innovation from research, it can come together with the innovation of entrepreneurship, also creating business, and that's, in this way, you can yourself create your own business. So what we do, we take some of these young professionals from different countries, we lock them for 1 or 2 weeks in a moon base. And they have to live there and work like they would be on moon base. We have one in Europe, we have one in Hawaii, we would like to build one in China Moon Mars, and there you can learn to solve problems like you would be an astronaut, using space research, and also developing innovation that after can spin off for social benefit. So that's a great program, and it's now a new area where we can develop capacity building in an international cooperation.
Okay, thanks.
Thank you. I think there are 3 things you have to understand in Chinese space programs. One is that the space science missions, we have the quantum experiments, we have the dark matter detectors, we have the soft X-ray, hard X-ray detectors, a number of other missions. These are the space science missions. And the second part is the explorations on Moon and Mars and beyond, and asteroid and many other planetary discussion, the exploration missions. And third part, of course, is the what we call the manned space flight programs, including the Chinese space stations and number of Shenzhou missions. These also, the 3 important platforms that we can use for our future studies, especially we based our education programs on this. And also in APSCO, we do, like Mr. Tian mentioned, the small student satellite programs that developed 3 satellites have been put into orbit for flights. And we're currently in the second part, which is the what we call ACC APSCO CubeSat competition, and that is similar to this competition program, but we also have a one nation, one mission programs. And all of these, as Bernard has mentioned about the knowledge-based, that APSCO is transferring from project-based into knowledge-based organizations. And we're also in an effort to establish an EBSCO university, which can cover all these efforts together and also put the, what you call entrepreneurship, we call it private sectors and commercial sectors, into our programs, into our efforts, that we can have educations, knowledge-based service products and commercial perspectives and services into the organization for the benefits of all member states of EBSCO. So that's our effort.
Great.
Thank you. I think for the technological advancement, quantum communication systems are important because we're speaking of deep space exploration, and for that we need a very advanced communication system, and we should not rely too much on ground systems, therefore. And one other aspect is, therefore, as it was mentioned, artificial intelligence and machine learning, where we need to make sure the spacecraft, satellites, all the payloads that we're sent have their own computing power and smartness to make decisions on the fly. One also important technology will be 3D printing. I think there is a need to have, and that's, I think, for all the young students, it's very important to try to focus on that, is if we can build directly from space with direction from the ground, that can be very great, and we can also reduce the cost for the launchers, for the weight. So all this is very important. Also, one more thing is the in situ resource utilization, the issue. Also is the future. We need to also find a source of energy or any material we can find outside our planet. So again, we're smart and don't have to transfer that from planet Earth to space, but use what we have already over there to do our missions.
Okay, cool. And we have still 3 rounds of discussions. Let's make it short. And nextly is about the importance of collaboration. We know this time all the universities, middle schools, they're joining in different teams. They're working together. So it's the same for the space exploration for humankind. So can you elaborate the importance of collaboration in the space exploration for humankind? Let's start with Mr. Xu, okay?
Well, I think space exploration is a very important part because it is an effort of humanity. I think it's a joint effort of all the nations to go together. Or we call it competition makes the pace faster, but cooperation makes us go further because we need to have a collaborative efforts of all international communities to play together for explorations missions. On that particular base, we do have a successful cooperation on the Chang'e 4 and Chang'e 6, putting a number of instruments on board the lunar surface and also on orbiting missions. I think also there is also a share of samples that has returned from the Chang'e 6, which is far side of the moon. It's also a very exciting part. I think the key word is to share and to work together.
Good. Yeah.
Yeah, so cooperation, this was my daily life because I was working at the European Space Agency. There are 24 countries, so I was a member of 24 countries. But it was not only because, for instance, I was part of the negotiation of the first collaboration between ESA, European Space Agency, and the CNSA for the first program of Chang'e 1, helping in data. So clearly, international cooperation is a key for different reasons. First, it's important because you use the skill of different countries, you learn to work together, you build peace as well, and you can train a culture of working together. But still, it's important to retain some competition. And what is the best competition we can have? Olympic Games. So let's have Olympic spirit. We try each of us to be the best possible of our ability. And then we go and we make a great celebration. Like I watched yesterday, the closing ceremony in the middle of the night of the Olympic Games, and I hope we'll continue in this. But now in cooperation, we have a very practical steps. Exchange data. Make data set data open and make the tool to analyze the data. And this way you will have many creative minds that will harvest the data. Also have opportunities of payload. international mission, like China has been very open on that, not only for the Lunar program, but also for the space station program. There have been programs also with the United Nations where some international people were on board. International Space Station is quite open, but has not been open to China, and it's a shame. At ESA we proposed at one stage that China should enter the International Space Station. The next generation of space station, let's find also some good ways where scientists contribute to both, like Professor Deng, he did that, but for many others. And then we put the vision for the moon, of Moon Village, a Moon Village which is for the benefit of all, for science, but also all society. And we have this into the International Lunar Research Station, a bit inter-Artemis agreement, but some special restriction. And we want to develop an initiative, it's called Space for All. We developed this initiative also with the United Nations, and we have a foundation called the Space Renaissance International, where we try to have space for all as a sustainable development goal 18 that will help all countries to develop space. So, and then look really that we do it also for social benefit for all.
Yeah. Thank you. And the next question for Mr. Niu and Olivier, that is how can we, what kind of measures and strategies can be used to increase public interest and support in this kind of space exploration?
I think international cooperation and also public events.
Engagement.
Yes. So these two ways are very important to raise public interest. For example, we can hold international events. We can also use the media and to raise the fund to international community and also use international organizations. Especially when there exist geopolitical issues, we need to leverage the international multilateral organizations. So these ways, there are many ways to increase this transparency and to get awareness of the public, and also this is also help to raise the fund for the collaboration.
Okay, Olivier?
Well, the Academy is actually, that's what they're doing for since 1950s. And that's why, if you remember the presentation, I show you the summit, the head of space agencies, where 35 head of space agencies were together. So doing this collaboration between the leaders of the world together and involving not only the leading countries, but also the emerging countries is extremely critical. I think it's important for the universities to collaborate between each other, and I'm glad today that we see that, but we need to involve even more. It's important for not only space, but space is really also Earth, right? We think of space because right now we're on planet Earth. We're speaking of Earth, but we're from planet Earth, so let's make sure we collaborate and we create this peace that is happening naturally when people collaborate. And I was very glad in April to see the launch of Shanghai 6, thanks for the CASC and the CNSA. And I was with a lot of team from France, from different countries, all participating and assisting to the launch, and all who prepared payloads on this mission. And it's beautiful to see, and I think this should be more in the news. There should be more, we should convey more this information, and the Academy has conveyed this information and will continue to do so for strengthening this international cooperation.
And I was there for the Chang'e 6 was launched, and we will make a very beautiful documentary about the Chang'e 6 and the story behind it. So we're looking forward to that. And my very last question goes to every panelist, because you all just mentioned this event has provided a very good platform for all the participants, for all the universities, entrepreneurs, and also experts to talk about these issues. So what do you want to say to these young talents who will devote themselves to the space exploration programs in the future? A few words for each of the panelists.
Engage more in the international collaboration project, such as our payload competition. Thank you.
Yes, I would say, okay, you have to use space for knowledge, for society. Space for peace, we have all to work on this. Space for all, also to include all disciplines, all branches of society, space for development. And we should not keep locked on Earth. We have also to go moon for all, and then we go beyond. And this will be a great opportunity for also getting benefits to society.
Well, I think we're in an exciting moment. We are going to Mars, we're going to the moon. Follow them. Follow them by providing your inspiration and your instruments. And also follow Professor Deng Yiling and his team, because he's making the best effort for benefiting all of us. Thank you.
Yeah, I agree with the last one. Yeah, I think it's important first to understand that space is the world in collaboration. Right now, the world, the scientific world, is communicating in English. And I know, I'm not an English speaker, by birth, so I had to work on it, and I highly recommend everyone who wants to be participant in the international cooperation at high levels to try to be very fluent in English. Simple, watch more movies about space in English. There are very convenient ways to try to be more and more fluent, but I highly recommend that you not only learn the language fluently, but also that you start to be involved, like you are today, in more workshops, presentation, conferences, and don't hesitate to interact, exchange between each other, and reach the people that you want to reach. So, yeah.
Yeah, so enjoy the competition and pursue your dreams. That maybe one day that some of your experiments will be sent into space. And ladies and gentlemen, we have come to the end of our panel discussions. I want to thank all our panelists. They have shared their insights and expertise with us today, and their perspective have illuminated the path forward for international collaboration and also the development of innovative scientific payloads. And we look forward to seeing these incredible achievements that will emerge from this international space science and scientific payload competition today. And may these innovative ideas and technologies will inspire the generations to come and pave the way for a brighter future in the space science. And so thank you once again for our panelists, and thank you all for joining us. I wish all the participants will enjoy the competition today. Thank you so much.
Thank you.
Please have a